With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Our question is integral from 0 to pi dx upon 1 plus 10 power cos x plus integral from -1 to 1 log of 2 minus x upon 2 plus x into dx. Okay, so assume this to be I1 and assume this integral to be I2. Okay, and I have to find the value of this. Okay, so here I take here I2, so I write here I2 is equals to integral from -1 to 1 log of 2 minus x upon 2 plus x into dx. Okay, so this is our, assume this to be fx, so I can write here fx is equals to log of 2 minus x upon 2 plus x. Okay, so if I replace x by minus x, so I can write here f of minus x is equals to log of 2. Okay, so here if I put minus x, so minus minus plus, so I can write here 2 plus x upon 2, and if I put here minus x, okay, on the place of x, so plus minus minus, so I can write here minus x. Okay, so I can also write it as log of 2 minus x upon 2 plus x whole power minus 1. Okay, so I simply reverse it and put the power in power minus 1. Okay, so both values same, and we know that log of a power n can be written as n log a. Okay, so I can write here f of minus x is equals to minus of log of 2 minus x upon 2 plus x. Okay, and we know that this is our fx, this log of 2 minus x upon 2 plus x is fx. Okay, so I can put this as f of x, so I can write here f of minus x is equals to minus of fx. Okay, so if any function satisfy this condition, it means that f of x is odd function. Okay, odd function, so the value of integral I2 is equals to 0. I2 is equals to 0. Okay, so if f of x is odd function, then the value of this form integral is 0. Okay, so the value of this I2 part is 0, and then I have to find the I1 part. Okay, so I can write here I1 is equals to integral from 0 to pi dx upon 1 plus 10 power cos x. Okay, and we know that f of x into dx, and the integral from 0 to a, I can also write it as integral from 0 to a f of a minus x. Okay, into dx. Similarly, I can write here, I apply this property in this given integral. So I can write here I1 is equals to integral from 0 to pi dx upon 1 plus 10 power cos. Okay, so here on the place of, if I compare these both, on the place of a there is pi. Okay, so I can write here pi minus x. Okay, and we know that cos pi minus x is minus cos x, so I can write here I1 is equals to integral from 0 to pi dx upon 1 plus 10 power minus cos x. Okay, so I can write it as I1 is equals to integral from 0 to pi dx upon 1 plus, this can also be written as 1 upon 10 power cos x. Okay, then I have to simplify it, so I can write here integral from 0 to pi dx upon, so here in denominator I have to take the LCM, so I have to take the LCM, so the LCM is 10 power cos x, so I can write here 10 power cos x plus 1. Okay, so on simplifying it more, I can write integral from 0 to pi dx. Okay, here it is 10 power cos x. So if I put, okay, so after simplifying it, I can write here, okay, so I have to write here this. On simplifying it, I can write here 10 power cos x into dx upon 10 power cos x plus 1. Okay, assume this to be second equation. Okay, assume this to be second equation, and this given equation, assume this to be first equation. Okay, now add equation 1 and 2. Okay, 2. So here left hand side are same, so I can write here 2i1 is equals to right hand side there is integral from 0 to pi, so I can write here integral from 0 to pi dx upon, okay, dx upon 1 plus 10 power cos x. Okay, plus here in second equation, this is the right RHS part, so I can write here integral from 0 to pi 10 power cos x into dx upon 1 plus 10 power cos x. Okay, we know that addition is commutative, so I can also write it as in this way. Okay, then I have to add, so I can add it. So here it is addition and the limits are same. Okay, and both place there is integration, so I can write here common integral from 0 to pi. Okay, and after adding this, I can write here LCM is 1 plus 10 power cos x, and here I can write 1 plus 10 power cos x. Okay, and here I can write common dx. Okay, so here this numerator and denominator are same, so I can cancel it. So the remaining part I can write here integral from 0 to pi, and here the remaining part is 1, and 1 into dx is dx. Okay, and we know that integral of dx is x. Okay, so I can write here x, and the limit is from 0 to pi. Okay, and here in left hand side there is 2i1, so I can write here 2i1. Okay, so here I can write 2i1 is equals to, upper limit is pi, lower limit is 0. Okay, so on putting this, I can write pi minus 0. So I is equals to pi minus 0 is pi, and here 2 is in multiplication, so I put it in division on right hand side. Okay, so this is the value of i1. Okay, so here I assume this given equation as in terms of i1 and i2. Okay, so the final answer is, so I can write here final, okay, final answer is equals to i1 plus i2. So the value of i1 is pi by 2, so I can write here pi by 2, and the value of i2 is 0, so the final answer is pi by 2. So the correct option is A, pi by 2. Okay, so thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.